Hello, we're back with some more unit conversion problems, and this one reads, an unknown substance has a density of 547 kilograms per liter. What is the mass and pound mass of 8 gallons of this substance? And we are given some unit conversions here, which is very convenient. Okay, so because this is a density problem, we know that density equals mass over volume, right? And we ultimately want to get the mass, and we're given the density and the volume. So we can rearrange this and write that mass equals rho v, or mass equals density times volume. And all we have to do is make sure these are in units that will cancel out. And as I suggested, you might want to calculate just the volume first and get it in the right units before multiplying it by the density. I think that will make it a little bit easier. Okay, so we have our volume, getting it into the right units. We have start out with the value we're given, 8 gallons, multiply by the conversion given, so that cancels out gallons. We now have meters cubed, and 1 meter cubed is equivalent to 1,000 liters. And then we get our volume is 30.2835 liters. Okay, so we know that mass equals density times volume. Alright, so now that we have our volume in the correct units, now is would be a good time to plug in the appropriate values. Okay, so our mass will equal the density given. So the density they give us is 547 kilograms per liter. And we're going to multiply that by our volume, which is 30.2835 liters. Okay, so if we left this as it is, we'd get our mass in kilograms, but we want it in pound mass, so we have to convert kilograms to pound mass, and we do have a conversion for that. 1 kilogram is equal to 2.20462 pound mass. And you can see the units all cancel out nicely, and we get our final answer in pound mass. So multiplying all this out, we get a mass of 36,500 pound mass. And I chose to round to 3 significant figures. Okay, let's look at another problem. This one's a little bit longer. I know you see this and you're probably thinking, oh, that is a lot of words. But if we break it down, I'm sure we'll get through it. Okay, so first they give us the dimensions of a lake. So it's 8 meters by 15 meters by 1 meter. Okay, so right away I'm thinking volume equals length times width times height. So we'll get to that. And part A, they want to know the volume of the liquid in feet cubed, and they give us a conversion. Part B, they give us the density, and they want to know what the weight of the liquid is in pound force and dynes, and we have some conversion factors here. So let's get started. So volume equals length times width times height, and we were given the 3 dimensions, the 15 meters by 8 meters by 1 meters. The volume is thus 120 meters cubed, right? And now we just want to get that into feet cubed, and we have a convenient conversion going from meters to feet, so we'll write that out. 0.3048 meters is equivalent to 1 foot. And we're going to have to do something different here that we haven't done before. Notice that this is meters cubed, and then we have meters and feet. We're going to have to cube this whole thing, and that'll get the unit feet cubed on the top and the unit meters cubed on the bottom, and that'll also cube the value 0.3048 in the denominator. So once we do that, we get part A, our volume is 4,238 feet cubed. Okay. So part B, let's remind ourselves what they want. We have the volume in feet cubed, and now they want to know what is the weight of the liquid in pound force and dynes. And we know that density equals mass over volume. So if you just want to get the mass, that's density times volume. And then the force is going to be mass times acceleration. Or we can substitute this into here. Force equals rho v a. And a in this case is 32.2 feet per second squared. And because we want the answer in pounds force, just how similarly when we had newtons, we want kilograms and meters per second. For pound force, it's different. We want the units to be pound mass and feet per second squared. But also, pound force is different. 1 pound force does not equal 1 pound mass times feet per second squared. These are the correct units we want, but the actual conversion was given to us on the previous page. It was that 1 pound force is equal to 32.2 pound mass times feet per second squared. So let's use this relationship right here and write it all out. So the density we're given is 85.3 pound mass over feet cubed. And we want to multiply that by the volume that we got, which is above 4,238 feet cubed. So as I do this, I like to cancel out the units and see what we have. So we currently have pound mass, which is looking pretty good. And now we'll multiply by the acceleration, or the acceleration due to gravity, which is 32.2 feet per second squared. Okay, so our current units are pound mass times feet per second squared. And we just said that that is not equivalent to pound force. We have to add one more conversion in here. And that was given to us, that 1 pound force is equal to 32.2 pound mass times feet per second squared. And putting all that together, we get the weight. And remember, weight is a force. 361,000 pound force. Okay, but we're not quite done yet. So we also want to get this weight in dynes, and to do that we're going to have to add the other multiplication factor here, which on the other piece of paper, 0.22481 pound force is equal to 10 to the 5th dynes. Okay, and doing that, we get the weight in dynes is equal to 1.61 times 10 to the 11th dynes. Okay, and let's box that, make it look a little clean. Alright, once again, thanks for watching. If you thought this was helpful, please leave a comment below and check out the other videos.